So in the previous two videos, we saw that how to solve an ordinary differential equation of first order and higher degree when it is solvable for p, and in the second video when it is solvable for y. In this video, we will see that how to solve these kind of equation when these equations are solved for x. Now, let us write this general notation for first order and higher degree equation. Let us give it a name, and this is our equation number one. Suppose it is possible to solve this equation one for x, though this form will be x is equals to some function of y and p. We name it equation number two. So next step we will differentiate this equation 2 with respect to y. So the left hand side will become 1 over p, and the right hand side will be some function of y p and dp by dy. So this is our equation number 3. Out of equation 3, we take out that factor which involve this derivative of p with respect to y, and this is a first order and first degree ordinary differential equation in p variable and y variable. Okay, and we solve this first order and first degree differential equation for p, and we get something like p is a function of y variable and arbitrary constant. Suppose this one is equation number 5. To find the general solution of the original equation number 1, we eliminate p from equation number 2 and equation number 5 to get the solution as x equal to function of y. P will be replaced by expression given in 5, and it will involve arbitrary constant. Let us take a couple of examples to understand how to implement these ideas in actual problems. So this is our example 1, and the example is we have to solve the equation is y equals to 3px plus 6p square y square. That this equation is solvable for x because x is in only one term, so we can express x as a function of y and p, right? So solving, suppose we name it as equation number 1 and we solve it for x, so it will become 3p x is equals to y minus 6p square y square. This it implies x equals to 1 over 3py minus 3p will cancel out from 3p factor will cancel out using this 3p factor. So this will be 2py square. And this is our equation number 2. X, we are able to express x as a function of y and p. Next step, we differentiate this equation with respect to y. So differentiating this equation with respect to y, we get d over dy of 1 over 3py plus 1 d over dy of minus 2py square. Further simplifying it, 1 by 3 comes out, and we have 1 by p multiplied by y. We use UV rule. First function 1 over p as it is. Derivative of y with respect to y is 1 plus y as it is, and 1 over p differentiation with respect to y, it will be minus 1 over p square dp over dy. Okay, now the second term minus 2 comes outside. This is minus 2. We have first function p as it is. Derivative of y square with respect to y will be 2y, and this one is plus y square as it is. Derivative of p with respect to y, this will be dp over dy. Further simplifying it, left hand side is dx by dy, so we can write it as 1 over py, because dx by dy is equal to 1 over dy by dx, and 1 over dy by dx we write by symbol p, using the symbol p, and this one is equal to, we are simplifying the expressions on the right hand side, so this one is 1 over 3p, then we have got minus 1 over 3 y over p square dp over dy, minus you got 4py minus 2y square dp over dy. Now bringing 1 over p to right hand side, we get this equation, this expression, this equation becomes 1 over 3p minus 1 over p minus 1 over 3p y over p square d, this is dp over dy. So this is dp over dy. dp over dy minus 4 py minus 2y square dp over dy equals to 0. So further simplifying it, this is 1 over 3p minus 1 over p, and this is same as 1 over 3 minus 1, and which will be minus 2 over 3p. Okay, we have simplified it, and we have 1 minus 1 over 3 y over p square dp over dy minus 4 py minus 2y square dp over dy. We have to factorize the left hand side of this equation. In the last two terms, if we take a minus 2y common, so the inside the bracket will be 2p plus y dp by dy. And similar common factor we need in first two terms. So in the first two terms, suppose we take out minus 1 over 3p square as common. So in the first two terms, so we take a minus 1 over 3p square. So inside the bracket will be 2 uh, p, right? So 2p minus 2 over 3 by p. Okay, this is done. And this one is plus 1 over 3p square we have taken out. So this will be plus y dpy over dy. So this is plus y dp over dy, right? And we are taking from last two terms, we are taking common minus 2 y. So minus 2y. So inside the bracket will be 2p, 2p plus 2y we have taken outside. So this will be y dp by dy. Y dp over dy. dp over dy equals to 0. Now in these two terms we have common factor 2p plus y dp by dy. So we take it out. So we have 2p plus y dp over dy multiplied by minus 1 over 3p square minus 2y, and this is equals to 0. We have here two factors. One factor involve the derivative dp over dy, and the another factor does not have this term. So we take out this factor which involves dp by dy to find the general solution of the given higher degree differential equation, right? The second factor will give us a non-singular solution, and here we are looking for general solution only. So we are taking this factor of 2p plus y dp by dy, we equating it to 0 and solving this equation for p in terms of y. So we have this factor t 2p plus y dp by dy, and equating it to 0 become a first order and first degree equation with dependent variable as p, and we give it a name, and we write it as equation number 3, which is a separable equation. So we are rearranging these terms. So this can be written as a y dp over dy equals to minus 2p, and we can further rewrite it as 1 over p dp is equals to minus 2 1 over y dy. This is separable form. 1 over p dp equals to minus 2 integration 1 over y dy plus arbitrary constant. So integration of 1 over p with respect to p is log p. This is equal to minus 2. Integration of 1 over y with respect to y is again log y. And we know that when all the terms involve logarithmic function, we write a arbitrary constant in terms of log. So arbitrary constant we are writing as log of c. Log p is equals to m. N log m is log m raised to power n. We can write it as log y raised to the power minus 2 plus log c. And this becomes log of p is equals to log m plus log n is log m into n. So this is a log of c y raised to the power minus 2. And taking anti-log, so this one is p is equals to c y raised to the power minus 2. And this is our equation number 4. And we find the solution of the first order and higher degree equation by eliminating p from equation number 2 and equation number 4. In this case, simply we'll put p equal to c y raised power minus 2 in place of p. So in equation number 2, so our solution is x is equals to 1 over 3. P we will write as c y raised to the power minus 2 multiplied by y minus 2 c y raised to the power minus 2 multiplied by y square. And this one is equals to 1 over 3c. Y minus 2 goes up and it becomes y raised to the power 3 minus 2 y raised power minus 2 into y raised power 2. This is y raised power 0, that is 1 minus 2c. And this is the value of x. So the solution of the original equation is x equals to y cube over 3c minus 2c. So let us take one more example, and here we have to solve x equals y plus p square. Because of p, this is first order equation, and because of p square, this is second degree equation. Okay, so this is ordinary differential equation of first order and second degree. Now it is already written in the form where x has been expressed in terms of y and p. So let us name it as equation number 1. And we can see that this equation is also solvable for y. So we can solve this differential equation using that method. So here we are solving it using the method equation solvable for x. Next step, we take a derivative with respect to y. So this one will be dx over dy equals to d over dy of y plus p square. Dx over dy, we can write it as 1 over p for the reason that dx of dy is equals to reciprocal 1 over dy by dx, and 1 over dy by dx we write by the symbol p. This is equal derivative of y with respect to y will be 1 plus derivative of p square with respect to y. Chain rule p square, that is 2p, and then dp over dy, right? So this can be written as 1 over p minus 1 equals to 2p dp over dy. Simplifying it, this becomes 1 minus p over p is equals to 2p dp over dy. Further rewriting it, this is first order and first degree differential, ordinary differential equation with p as dependent variable and y as independent variable. And this one is a separable form, right? So rewriting it as dp and bringing all the function of p with the dp. So it becomes 2p into p. This will be 2p squared. So this will be 2p e into 2p square over 1 minus p, and this one is equals to dy. This is separable form. Okay, so we integrate this, and we have integration of 2p square over 1 minus p dp is equal to integration of dy plus arbitrary constant. So we have here, we have to integrate p square over 1 minus p. How to integrate it? And this is 1 over minus p is in denominator. So we can write p square as p square minus 1 plus 1. So before that we bring out 2. So we can write it as p square minus 1 plus 1 over, let us take out negative common from 1 minus p, so this is minus 2, it becomes p minus 1 dp equals to integration dy plus c. Now we have minus 2 common, p square minus 1 can be written as p plus 1 into p minus 1. This is plus 1 whole divided by p minus 1 dp. Integration of dy is y plus arbitrary constant c minus 2 integration of this is p plus 1 into p minus 1 over p minus 1. We are separating them out, and this one is plus 1 over p minus 1 dp. This is equals to y plus c. This factor p minus 1 cancels out, and we have minus 2 p plus 1 integration with respect to p plus integration 1 over p minus 1 dp. This one is equals to y plus c, right? So I've cleared the clutter, and we have got this minus 2 integration of p with respect to p. We have p square over 2 plus integration of 1 with respect to p is p, and this one plus integration of 1 over p minus 1 with respect to p. This one will be log p minus 1. This is equals to y plus c. So we can rewrite it as y is equals to c minus p square minus 2p plus minus 2 log p minus 1. Now the solution of the original equation is obtained by eliminating uh, uh, p from equation number 1, and let us write it as equation number 3. Okay, so in this case, this elimination process is difficult because it's difficult to solve explicitly p in terms of y and c from equation number 3. So we will write a final answer as the solution of the given uh, first order and second degree equation 1 is obtained by eliminating p from equation number 1 and equation number 3. We obtain the required solution by eliminating p from equations 1 and 3. So in this video we learned how to find general solution of ordinary differential equation of first order and higher degree, those kind of equations which are solvable for x with the help of two examples. Thank you.